If I pass back an extra, just hold on to it for a second. Alright, so in a quadratic function, that's going to be your first definition, and these might be on your test. In a quadratic function, the greatest exponent is 2. So if it has a power greater than 2, an exponent greater than 2, like x cubed, then it's not quadratic. And they have 3 terms. The first one's the quadratic term. And how do you know which one that one is? It's going to have an exponent of 2 beside it. Quadratic. The next one's linear. That just has an x beside it, like this. And then constant just means that it's just a number, no letters. So those are the 3 different types of terms, and they're always going to be in this order. Alright. The graph of a quadratic is what did you say, Caleb? Parabola. Looks like a U. Looks like this. I'll let everybody copy down that first. Can you turn your music down a little bit? Thank you. Alright, y-intercept, that does not change. Like, same thing as a linear equation. How do we find a y-intercept? Alright, let's review. If I gave you 2x plus 3y equals 6, what would the y-intercept be? What did you say? 2. How'd you find that? Yes, set x to 0. Same thing here. For y-intercept, write that down. You set x to 0. Same thing with quadratic as we did with linear. Alright, this little thing right here, this dot that's in the middle, is called your vertex. That's just a fancy word for saying the middle of your parabola. Vertex is the middle. And this line going between it is called axis of symmetry, this vertical line. And what that means is that parabolas will always be symmetric. Like you could take this side, fold it in half like a sandwich, and it would be the same thing on this side. So it's always going to be symmetric on both sides. Vertex always in the middle. We already talked about the y-intercept. These are the formulas for the axis of symmetry. Negative b over 2a. You will need to know that for this class, for pre-cal, for analytical, for calculus, literally every math class. Axis of symmetry is always negative b over 2a. Negative b over 2a. Negative b over 2a. What's the formula for the axis of symmetry? Good. Don't forget it. Okay. So we're going to find these 5 things for each quadratic. And that's why you'll have a graph paper, because on part C we're going to graph it. But it looks like a lot. It's not very hard, and you'll see that. First thing, part A, is find the y-intercept. Again, how do we find y-intercept? Well, when we set x to 0, it's just going to be what? 8. Everybody see that? So, how could I shorten that up? Your y-intercept's always going to be your, what's this term called? Constant term. It's always going to be your constant term. So, tell me the y-intercept. As a point? Yes. Always going to be that last term. Done with that one. Next one says equation of the axis of symmetry. What's the formula for axis of symmetry? Good. Alright. Can y'all tell me what you think B would be from this quadratic? Yes, the one in the middle. That means A in this problem is what? The number in front. 1. B is what? C? Good. So let's plug that in the formula. This says negative B. Our B is already negative, so it'll be a positive what? Over 2 times. Good. So our axis of symmetry will be, and here's how you write it. It's a vertical line, right? So you write x equals 3. That's our axis of symmetry. It's a vertical line. Questions about that part? Now it says find the vertex. Vertex is a fancy word for the middle, center. Well, the axis of symmetry, if you look up here, doesn't it always go through the vertex? So doesn't the vertex and the axis of symmetry have the same x value? So what's the x value of our vertex? Yes. How do you think we find the y? the y value of our vertex. That's our y-intercept. And this one we know it couldn't be the y-intercept because this x value is what? 0. Ours is 3. But how did we get this? We plugged what in? 0 in for what? So what do we do for here? Plug 3 in for x to find our y. Very good. So 3 squared is what? 9. Minus 6 times 3 is? Good. Then we have plus 8. What's negative 9 minus 18? This part first. What's 9 minus 18? Plus 8. Yes, that's our y value. So the middle of our parabola will be at 3, negative 1. Now moving on to part B. It says make a table, we already know how to do that, of x and y values with the vertex. It says includes the vertex, but put this out to the side. Vertex in the middle. Because it's in the middle of our parabola, we want it to be in the middle of our table. So for our table, x and y, in the very center we'll have what x value? And on our y, now we want to find two values less than 3. That's going to be what? 2 and then 4 and 5. Very good. Let's start with the one up here. How do we find the y value? Plug what in for x? 1. Let's do the 1 first. Go ahead and plug 1 in for that equation, and I'll give you time to do that in your calculator. You can just plug it straight in, and then tell me what you're going to get out loud whenever you find it. 3. Everybody agree? Now plug in 2. What'd you get? Good. Go ahead and do 4. What'd you get? Good. Go ahead and plug in 5. And you can say it out loud whenever you get it. 3? Did y'all say 3? What do we notice about the y values? Yes, these are the same. These are the same. You know why? Because a parabola is like a sandwich, right? You fold it, it'll be the same on each side. So, when you're doing the table, do you have to do all of these values? You can just do the first what? Do the first 3, then plug these in using symmetry. Does that make sense? Okay. So now you're going to graph these points on your graph paper. Go ahead and do that. Don't use the whole graph paper for one graph, please. Y'all know I'm running low. Just do a little corner and make this graph on your own. So make your own x and y axis. It shouldn't be very big because you know the numbers aren't very big on this one. I'll show you what mine looks like. And make sure you label your graph number 1 so that way you can tell when you go back and look at your notes which one goes with which. Alright, what's this little dotted line right here that I have going through the center? Yes, you need to draw that on all of yours because you'll get to ones that we don't know all the points. Say if I only knew these 3 points right here. Say if I didn't know how to calculate these, maybe I didn't know how or couldn't find them. I could find these points just using the axis of symmetry. And this is how. I look at the axis of symmetry, I see that this is 1 away. So I could just move this one away. I could go to right here. Okay, this is 2 away from my axis of symmetry, so I'll go 2 away, draw a point. So you need to draw your axis of symmetry on all of them, because on some of them you won't be able to find 5 points. Does that make sense? Any questions on that part? Alright, going back to your paper now. It says for part D, determine whether it has a min or max value and find that value. By just looking at the graph, what do you think, just your thoughts, would this graph, this parabola, have a min or max? What do y'all think? Alright, why would you say min, Connor?
Because I have no clue. I just picked the first thing I saw.
Yes.
It's because it doesn't go any lower than -1.
Yes, so like a minimum means it can't go lower than something. Like there's a restriction. This one, this is the lowest point, right? Why wouldn't it be a maximum? Because it keeps going. Like if I were to say, what's the maximum value? You wouldn't be able to tell me, because this goes on forever and ever and ever, right? But if I asked you the minimum value, you would tell me it's at this point. Draw a dot or a star right there. So it has a minimum. And minimum, again, we were just talking about up and down, right? What value is talking about up and down? Your y value. What's your y value at this point? Yeah, it's our vertex, right? So you would say has a min of, what's the y value again? Good. And now you have to tell the author or me or whoever's writing your test where at. So at x equals what? What's that x value right there? Yes. So the min and max is the same thing as your what? Vertex, always. Okay. Now part E. Remember when y'all did piecewise functions way back when, and it was difficult to find domain and range, like the hardest thing ever? That is the hardest thing. That's the hardest function to find the domain and range, piecewise functions. Everything else that we'll do in this class, super easy to find the domain and range. Okay. Domain is talking about which values? X and y, so left and right. Would this go on left forever as it goes this way? Yes, right? As this keeps going, it's going to go left forever. So what's the domain going to be on the left side? Is it going to go right forever? Yep. So it's going to be... Now think about every parabola that you've ever seen. Is it going to do this? Yeah, every time, right? Parabola is always going to be like this. So for quadratics, it's always going to be this for your domain. Every time. Every time. Now for your range, though, you just said that the lowest point is what? And you said that the highest point would be... Yep, that's it. There's no skipping y values. You don't have to worry about that. It's always going to be an interval for each one. Domain's always going to be this. And then your range has to do with this part. Alright, everybody good with that one? Let's do one more together. Number 2. Alright, starting with y-intercept. Tell me quickly. Y-intercept. How'd you know that? It's the constant term. Good. I like when y'all use math language. Makes me happy. Alright, axis of symmetry. Tell me the formula without cheating. Good, Simon. What's our b in this problem? So what's going to be on top? Just 10. 2 over what? Times -5. So it'll be 10 over...
-10.
So my axis of symmetry, tell me how to write it correctly. Equals?
-1.
Sweet. That's our axis of symmetry. Next we'll find our what? Vertex. What's going to be my x value of my vertex? Yeah, same as your what? Yep, same thing here. These go together. How do we find our y value for vertex? Go ahead and plug it in on your own. What'd you get? Negatives are tricky. Let's go over this one because this -5 is going to throw you off sometimes. If you plug in -1 here, Let me write it out like this. What is negative 1 squared? A positive. But this is still a negative 5 on the outside. Everybody see that? So what's positive 1 times this going to be? Still negative 5. This would make plus 10 plus 6. So this would make 5 plus 6 would make 11. So don't let that negative throw you off out here. It's still negative because the 5 is negative. Next we're going to make a what? Table. Good. What's going to go in the middle? Our vertex. Alright, 2 numbers up here. Go ahead. And good. Before you start plugging, we already know one of these. Which one do we already know? Yes, because we already plugged in 0 up here for x, right? So this one's going to be 6. What else is going to be 6? Just plug in 1 now. And somebody can just say it out loud whenever they find it. What'd you get? Good. That's what I got. Did everybody else get that? Alright, when you graph this, and you're going to go ahead and do that, make sure your graph's big because your vertex goes all the way up to 11. So make it fairly large so it can fit on there. And then my graph's up here if you want to compare what yours looks like. Is everybody done with the graphing part? Cool. Does this one have a min or max? Yes. This one has a max. Of what? At x equals what? Very good. Max of 11 at x equals negative 1. That comes from the vertex. Alright, so what's my domain? Good. Range? Y'all know that song started from the bottom? I know you do. Alright, so think about your graph. Start from the bottom. Negative infinity. Good. Now we're at where? Very good. I thought I was too old to know that song. Any questions on that? Alright, then do number 3 on your own. If you want to, you can compare your graph with people around you once you graph it. If you need help, please let me know. This is really important to get if you're going to take pre-cal next year, which I hope most of you are. If you need more graph paper, let me know. I can purchase some more. Bless you. When y'all get done, go ahead and discuss it with each other. If you're still working, just keep working.
Yeah, it was, did you give it up to your question? Okay. Very good. I'll put it in.
Alright, we ready to go over it? Cool. Okay, I'll just call on some people to help me out. Bryant, what'd you get for the y-intercept?
0.5.
C, correct. Very good. What did you get for the axis of symmetry, Rihanna?
2.
Did everybody get 2? Yes? Okay, so what is my vertex, Toby?
2, 7, or 2, -7.
Did anybody else get -7? Alright, let's talk about why he might have made a mistake. What do we do with this 2? We found the 2, we got to do what? Alright, let's do that together. If I replace all of these x's with 2, and most people mess up on this part, because people put the exponent out here, and then they would do what? 4 squared, right? But this is supposed to be what? 4, so exponent first, then multiply the 4 times, and get 8 minus 16 plus 5. That gives us what right here? -8 plus 5, so our vertex is 2. Good. Everybody okay with that part? Alright, Amy, tell me the x values you use, starting with the first one.
0, 1, 2, 3, 4.
Oh, okay. 0, 1, 2, 3, 4, good. Alright, tell me all the y values, William, starting with the top one.
5, -1, -3, -1, 5.
Everybody agree? Okay, so here's what your graph should look like. Everybody's look like this. Everybody's good? Alright, so really, would this one have a minimum or a maximum? Good. Of what? At domain? Range? Bracket? And good. Y'all feel good about these? Sweet. Let's look at the next one then. Because it says, or first of all, let's look back at the three we just did. I want y'all to look at what the min, whether it has a min or max, 1, 2, and 3, and I want you to talk about what do you think determines if a function has a min or max. Y'all can talk that out loud or to each other. What do you think determines whether it has a min or max? Alright, what do y'all think? Go ahead, Nikki.
If A is positive or negative.
Did y'all hear her? If A, which is the first number, right, is positive or negative. Notice in 3, it had a positive 2, in 1, it had a 1, and they both had what? Min, because they are shaped like this, right? Oops, hold on, you can't see. Like this. And then if it's negative, it's shaped like what? Upside down, and then it has a max. Does everybody see that? So over here, put A equals negative. That's when it has a what? Max. When A is positive, that's when it has a what? Min. And we already discussed this, but your max and min value is the same thing as your vertex. Good. So all you're doing here is finding the what? If it's asking for max and min, vertex. Good. So tell me how you find the x-coordinate of your vertex. Think about it. Good, because isn't the x-coordinate the same thing as your axis of symmetry? Yes? So your formula is negative b over 2a. What is our b in this case?
12.
Careful. Alright, because b is always the number beside which one? X. Is there an x here? No. There's a what? X squared. There's no middle term. Everybody see that? So it's 0. Oh gosh. Snuck up on me there. Alright, we'll start here Monday.